Good afternoon, everyone, and welcome back for part 2 of our professional learning coding series for grade 3 and 4 students, part 2 of our Transformation School program. My name is Nina Nesseth, and I'm a staff scientist at Science North. I am joined today by my colleague, Max Forte, who is just behind the scenes. Hi, Max.
Hello.
So Max will be overseeing the chat today. So if you have any questions during our lesson today, then you can put them right into the chat for a live conversation, and Max will be answering as we proceed through our coding. As well, Max will be dropping important links into the chat as we go today. So keep an eye out for messages from him. And before we begin, I would just like to begin by acknowledging that we are on the traditional and ancestral lands of the Atikamekw, Anishinaabeg, and Wahnapitae First Nation. We would also like to acknowledge the Métis Nation for their cultural and economic contribution in this area. These lands sit in the Robertson-Huron Treaty area, and as we are all treaty people, it is important for us to all be thinking about what treaty area we live in and are an active part of. Let's take a moment to appreciate the land that we are on by acknowledging the traditional territory and treaty area that you're located in. And just a few housekeeping notes before we begin. I just want to point everyone towards our Science North website. We have on our schools.sciencenorth.ca page an ample amount of resources for you to use within your classroom. And that includes professional development workshops, such as our session that we're participating in today, as well as, it's hard to see in this image, but in this sidebar here, there is a link to access our Science at Home series, which is a collection of lesson plans and resources for delivering virtually for synchronous learning for K-8 STEM activities. So these are all full lesson plans and activities that make use of resources that are very easy for your students to assemble from stuff they may have around the house. So the goal with these lessons are to make synchronous learning as painless as possible and fun. And as well, in terms of resources, on our education.sciencenorth.ca site, we have all of our resources for our professional learning coding series. You can see this blue banner in the middle here will actually point you to every lesson that we've delivered so far, including the lesson plans, handouts, answer keys, and coding guides for these lessons, as well as the recordings for the live videos that we are delivering right now. The video for today's session will be up on the site, most likely later today. So if you want to revisit it at any time, you can do that. So yesterday, we spent some time going through an unplugged classroom activity, which took lessons that you are already teaching about transformations and applied coding logic to them. So the goal of the activity yesterday, while on one hand, it's reinforcing our learning about transformations, on the other hand, it's also building foundational skills for breaking down complex movements or transformations into a series of steps or an algorithm, which is very useful for the coding that we're going to be doing today. As well, we looked at our coordinate systems and XY positions, which we will also see in our online session. And as well, the lesson that we're looking at today applies very, very strongly to our grades 3 and 4 algebra coding expectations, as well as to our geometry and spatial reasoning expectations, specifically for location and movement for both grades 3 and 4. All right. So at this time, I encourage everyone to open up Scratch. If you have the desktop application, that's fine, but it's not required for this activity. If you go directly to the website scratch.mit.edu, I will actually switch to the online version so that I can guide everyone to the programming screen. So if you've never used Scratch before, it's not a problem. It's actually a very intuitive application. I'm just going to switch over my screen. There we go. So the main page for Scratch will look something like this, which has a lot of information. But if you just go to this Create tab at the very top of the screen, you don't need to be signed in and you don't need to have an account. If you just click on that Create tab, it will lead us directly to our programming screen here. And we'll see that we have a whole menu of blocks on our left-hand side of the screen. In the middle, we have a blank space where we can build our program. And to the right, we have what's called our stage, which demonstrates the output of our program. And then at the bottom right, we have a panel for sprites and backgrounds. So those are the main areas of Scratch. I'm actually going to switch over to the desktop version on mine. So I'll just be 1 second. There we go. And you can see the desktop version looks almost the exact same as the online version of the application. So what we're going to do before we begin is we're going to prep our application for our activity, just because we need a few special settings to get this activity going. The first thing that we're going to do is we are going to add an extension called the pen tool. And the pen tool is a really neat extension that's made for Scratch, which allows us to draw with our sprites. So the sprite here is a graphical element. Here it's our Scratch cat that we can actually see in our staging area. To add the pen tool, the pen extension, we're going to go to this blue block in the bottom left-hand corner of your screen. And then just click it, and it will bring us to an extension screen. And the pen extension should be the second extension right here. So if you just click it, it will automatically add this set of teal blocks to your block library. And the second thing that we are going to do to prep our program is we are going to add a grid to our screen so that we could better manipulate our shapes and perform transformations using a coordinate system, using a grid. Scratch, unfortunately, does not have a very straightforward grid system. So the way that we'll have to add our grid is by applying a background. And we find the backgrounds down on the opposite end of the bottom of the screen. So on the bottom right-hand corner, there is a little round blue button, and it will expand a menu and choose a backdrop. And if you click on that, it'll bring you to a backdrop library. And we can use the search bar to just type grid. And you'll see that it'll give us a few different options here. Now, the two most grid-like images here are labeled XY grid 20 pixels and XY grid 30 pixels. So that means that the grid, once we select it, the one for XY grid 20 pixels, for example, will have its grid lines at every 20 pixel mark. So that means, and then for the XY grid 30 pixels, the grid lines will be placed at every 30 pixel mark. So that means that with this grid that we chose, so I chose the 20 pixel one, that instead of counting each square on our grid as one step, we're going to have to count it as a factor of 20. So this will be good practice for your students in terms of multiplications and counting by 20s. because, for example, if I'm moving along my x-axis here from 0, 0, which is my middle point on this grid, instead of going 1, 2, 3, I will have to go 20, 40, 60, and so on. And the last thing that we're going to do before we begin is make our sprite cat a little bit smaller, because as you can see on our screen, it's very big and it takes up a huge number of squares on our grid. So if we tried to draw with our scratch cat with our sprite this size, we'd obscure a lot of the lines of our drawing. So to change its size, we're just going to go down into the sprite panel right here. And in the size field, we're just going to choose a smaller size than 100. I'd say about 10 or 15 pixels will be enough. So if I do 15, we can see now I have a really tiny cat. I'm just placing it right in the middle of the screen. Okay. So now that we have all of our settings in place, we can start coding our shapes. Before we start with transformations, we want to start with just drawing basic geometric shapes using Scratch. So I'm going to give an example of drawing an equilateral triangle. And that will be the only shape that we'll do today in our session. However, in our coding guide, we have examples for a whole suite of geometric shapes that you can practice with your students that include triangle, rectangle, square, and a few other polygons, I believe a pentagon, hexagon, and octagon. And your students will find a very specific pattern that occurs, especially when they try to do equilateral shapes using this program. But we'll start today with a triangle. So to begin our triangle, we're going to start by going to this yellow events tab right here. So the events buttons are the blocks that give us our triggering events that execute our program. So the one that we're going to use, and I'm just going to pause for a second because I saw a great question. So for the question that we just got about missing the beginning of the video, just a reminder to everyone that the whole session's video will be shared in the resources page found at education.sciencenorth.ca. So we'll use this when green flag clicked. So that's going to be the block that we're going to use to start our program. So this block here just means that when we click this green block, green flag at the top of the screen here, at the top of our stage, that's going to be the element that initializes our program. So that's the one that starts everything. And now we're going to go down to our very last pen menu here. And we are going to set up a few settings for our pen so that it's nice and visible when we go to draw our shapes. So the first block we're actually going to choose is this very top one that says Erase All. And we want this one to be at the very beginning of our program because whenever we restart our program, we want it to erase the marks that we made previously so that we can start with a clean slate. Next, we're going to choose this Set Pen Color To button or block, and we're going to connect it directly below the Erase All block. And if you click on the reddish area here, it will bring up some sliders so that we can change the brightness and what color our pen ink, our digital ink, will appear. So I'm going to choose this bright red color for our first triangle. The nice thing about being able to set your pen color is that we can actually change the color that we're drawing with each of our transformations. So we can identify which triangle is pre-transformation and which triangle is post-transformation. Next, we're going to choose this Change Pen Size. It says by 1. And we are going to connect it just directly below the previous block. We're going to make our pen a little bit bigger. Let's say 5 pixels. For reference, each of the grid lines on our background right now is about 1 pixel wide. So by changing our pen size to 5 pixels, it'll be about 5 times as wide as our grid lines. It will make it a lot more visible when we do our drawing. All right, so those are our presets for our pen. Now we want to pre-establish where we want to start drawing. And to do that, we will need to start applying coordinates. So we'll notice too that the coordinate system that we are using today is a 4-quadrant system, which will be an early exposure of a 4-quadrant Cartesian plane for your students. But it is a good practice, of course, for coding. And we will be using some negative integers as well. So it'll be a little bit of early exposure to some of these math concepts. So in the blue motion tab, which is the very first menu in our block menu, I want you to select the go to x equals 0. Right now it says x equals 0 and y equals 1 because it is actually, and yours may have different numbers because it's actually pulling the value directly from my sprite right now. And we're going to set that to x is 0 and y is 0. So that we couldn't really see the shift on my screen, but it's moved my sprite right into the middle of the screen. Oh, well, actually, I won't do it until you press the green flag because we set our rule to say that our program won't start until we click the green flag. All right, the next thing we want to do is tell our program what direction we want our sprite to point, because that will dictate where it starts to draw its line and in what direction. So in the same blue menu for motion, we're going to choose this block that says point in direction 90. And we're going to leave that value at 90 for now. So that should face our sprite so that it's pointed directly along this x-axis to the right-hand side, so that first quadrant there. And then next, we're going to go back into our pen blocks, and we are going to choose the pen down block. So there are 2 blocks that are very, very crucial to using the pen, and those are the pen up and pen down blocks. Arguably, these are the most useful blocks for the pen tool. And you can think of them as being akin to writing on paper. If you don't have your pen down on the paper, you aren't going to be able to draw anything because the pen tip is not making contact with the drawing surface. So when the pen is down, we get marks on our virtual page. When the pen is up, it's as if we're holding our pen in the air, and so we won't be putting any marks onto the page. So we want to make sure our pen's touching the page. And now we're going to code for the steps that we need to build our shape. Now, when you're going through the steps with your classroom in terms of the rules for every shape that you're going to be drawing, it's worth talking through your students about what each shape needs. So how many sides does a triangle have, and how many corners? And for example, if you were doing a square, what angle we need to turn at. So we know we have like our 90-degree turn. Triangle's a little bit trickier. And how many times you have to sort of repeat. So you would repeat the same steps of moving to draw a line and turning a corner 3 times for a triangle because there are 3 sides and 3 turns. For a square, we'd repeat 4 times. And your students will get a lot of practice with this sort of logic, with this part of the activity. So if we head into this light orange control menu, there is a block here that says repeat 10. And this is a loop. So anything that we put into this sort of open mouth space on this block will be repeated. Now, we mentioned earlier that we're doing a triangle with 3 sides and 3 corners. So we are going to repeat everything that we have inside our loop 3 times. Now to draw our triangle, we're going to go back up into our blue motion tab, and we are going to choose this very first block that says move 10 steps. And we're going to place it right inside of the mouth of our orange loop block. And you can see that the block expands to fit my block. Now, if I just left this as move 10 steps, my sprite would only move the distance of 1/2 of a square on my grid. Because if you recall, each grid line is at a 20 pixel mark. And moving 10 steps, steps in Scratch are equivalent to pixels. So we want our triangle to have a side length, just so it's easier for our students to count. And to measure the sides of our triangle, we want it to be a factor of 20. So let's say we'll have our sprite move 60 steps. So it should move across 3 squares on our grid. And then next, we're going to add a turn. And to figure out our turn, we know that a full circle is 360 degrees. And we have 3 turns in our triangle. So our turn will have to be 120 degrees to make an equilateral triangle. So, and absolutely can allow your students to experiment with degrees to see if they land on the right one. They may have to try making numbers bigger or smaller and notice that their sprite will either cross past the point where it needs to stop, and they'll have to adjust their numbers up or down until they meet the corners in the appropriate places. And now we have our basic program. So if I go ahead and press the green flag now, I'll make this a little bit smaller so we can see the full program on screen. If I press the green flag up here, I've now drawn a triangle on my grid. So that's going to be our base program for drawing our shape. Next, we're going to translate this shape. So what we're actually going to do is we are going to make a copy of this first program. We can use the same program to do our translations, but I think for comparison's sake, it would be valuable for students to see our base program for our first triangle that we've drawn and our duplicated program with the changes that we've made to show our second program, or our translated triangle rather. So it's really easy to duplicate programs in Scratch. All you have to do is right-click on the top block for whatever you want to copy. So for example, if I wanted to copy just the lower half of this program, I would choose the very first block of the segment that I want to copy and press duplicate. And that will give me a section of code. And but if I want to copy the entire thing, then I can choose duplicate with the top block here, and it should copy my entire program. Now, Tara, I see your question, which says, I was doing this at the same time, and your triangle turned out colored in solid red. I'm not sure why. I'm not sure why either. That's very interesting. I believe Max may be formulating an answer for you, and he'll get back to you shortly. It may be your pen size that is affecting your shape, but I'm not quite sure why you have a filled-in triangle on yours. Thank you for sharing your observation. We'll get back to you shortly. On your screen right now, you should have two copies of the same program. And the second one that we're going to do is going to be our translated triangle. So if we choose here, the second program here, this copy is going to be our translated one. I'm just going to go ahead and change my pen color so that it is, we'll say this cyan color. And I'm actually going to go ahead and add some pen up blocks as well, because we're going to move from one program to the next, and we don't want our pen to draw in between our programs. So I'm going to add a pen up block to the bottom of each of our programs here. And so our next step will be to change the location at which we are going to draw our second triangle. So we have our first triangle here that draws starting at 0.00 and then moves 3 blocks to the right, makes our 120-degree turn, moves 3 blocks, and then makes another 120-degree turn, and then moves 3 blocks to complete the triangle. So we'll see this program here has the exact same instructions, but we wanted to draw in a different portion of our grid. So for example, we can ask our students to translate our triangle so that it is 1, 2, 3, 4, 5 blocks up and 1, 2, 3 blocks to the right. So if we practice our counting by 20s, then 5 blocks would be 20, 40, 60, 80, 100. And so that would be our Y position here. So our up, whenever we're moving up and down, we're changing our Y position. So we would move our Y to 100. And to move 3 blocks over, that's changing our X position, or our side to side. So we'd be moving 20, 40, 60. There we go. So now if we test our program, both of these squares might, So this did not do what we wanted. And actually I am going to say that there was a block. I understand why our block is getting filled in, and it's because we have the wrong block in our code here. And I believe John made the same observation, is that we have the block here that says change pen size by 5, which is increasing our pen size every time we draw our triangle. So we actually want the block that says set pen size, which is a very different rule that we're giving to our program. So instead of changing or increasing our pen size, we're just setting it at a set point size. It's easy to get those 2 blocks confused. So to switch out which block is in your program, it's just as easy as grabbing the block below the block that you want to move and dragging it downwards so that you're separating out your program. And then you can separate the block that you don't want and just drag it over to your library to remove it. And the one that we actually want is this very last block here that says set pen size to 1. So we'll grab that one and we'll replace it, and we'll reconnect our blue blocks here so that everything's all in one piece. And then we'll reset that to 5. And I'm actually going to add one more thing. So right now, that looks a lot nicer. So another great thing that you can do is, because we have these 2 separate programs here, instead of clicking the top flag up here, we can actually click on individual programs in our panel here. So when you click this top block here, it will run the program for our first red triangle. And if you click the top block here for our translated triangle, you can click that one and it will draw our translated triangle. If you want both triangles on the screen at the same time, it's just a matter of making a few small changes. So we can remove, for example, this erase all block so that we're not removing our entire markings so far. So I just separated out, dragged down the blocks we're keeping, separated my erase all block and dragged it over to get rid of it. And now I can draw my first red triangle and my second translated triangle. And you can have your students experiment with different XY coordinates. And again, they're all factors of 20, unless you want to move half blocks. In that case, you can use factors of 10 and 20. And have your students practice with these translations until they are comfortable with using this XY system to move their triangles around. Now to do a rotation, it's very similar. So let's copy our first program again. So we'll do that by right-clicking on the very top block of our program. So this is the one that has our pen color set to red. And we'll press duplicate. And I'll put this one just right underneath here, and I'll scroll down so that we can see it. Now let's get rid of that erase block again. So I separated my bottom half of my program and just dragged away my erase all block. And we'll give our rotated triangle a new color. So let's say green this time. There we go. Now rotations performed in Scratch very simply just involve changing the direction in which you're pointing. So if in this case, we're rotating around this origin, so this 0, 0 point, and we are changing the direction from which our sprite is pointing when it first draws its, when it first begins to draw the shape. So if we click on the value here where it says 90 on the blue point in direction block, it will bring up a sort of dial. And we can see that when we're pointing in direction 90, that we're pointing straight towards the right on the x-axis. So for example, if we want to rotate our triangle, here we go, by 90 degrees, you can do it manually, but for our students at this level, I feel like controlling using this visual dial would be much more accessible for them to do our quarter turn. So now we have our sprite pointed in the 180 degrees direction, so pointing straight down in this case. So if we go ahead now and test this program out by clicking the top block here, we'll see that we have a new triangle drawn that has been rotated. And just to make it a bit bigger so that we can see, you can see our rotation. And students will be able to test this program out with various starting directions that will complete a full circle. And if you want to change the starting location of that block, it's a matter of changing their XY position at which they start. And last but not least, we are going to perform our reflection. So to perform our reflection, we're going to copy our program one more time. So if we right-click right here and choose our duplicate. We'll place, oh, let's actually duplicate our first program again. Oh no, this one's fine. So we'll duplicate our program. I do recommend that when you're duplicating the programs that you do start with by duplicating the original triangle, just so that we are performing our transformations on this first red triangle here. So I will actually go ahead and do that. So right click our first program that we made and place it into our canvas. Again, we'll get rid of our erase all block. There. And then for our reflections, what we need to do is pretty much keep everything exactly the same, but change the direction by which our triangle is turning when we make the turns for our different corners. So the turns while we're drawing the corners of the triangle. So inside our loop where we programmed how to draw a triangle, just take that turn 120 degrees block and drag it away. And the one that we used previously was a turn clockwise 120 degrees. And instead, choose the turn counterclockwise block and place it in the exact same place. And so if we put in that we're turning the 120 degrees, and we'll make sure to change our color of our block. I'll do this orange yellow color. That one might be hard to see. I'm going to choose pink. So now if we execute this program, everything is the same except the direction in which we're turning while our sprite draws with the pen. And you see, once I've drawn this program here, that our sprite is following the same pointing direction 90, but instead of turning clockwise to draw a downward pointing triangle, it's turning counterclockwise to draw an upward pointing triangle. So we have a reflection. The line of reflection is exactly on that one side of the triangle there. If you wanted to separate out your triangles vertically, for example, it would mean moving your triangle up by translating it using the XY coordinate systems. So these are the 4 basic programs for performing different translations or transformations on geometric shapes. The great thing about these programs here is that they can be applied to any shape, not just triangles. And as I mentioned, in our coding guide, we have sample code for a number of different shapes from squares to octagons. But as well, because they're so modular, you don't have to necessarily teach all of these transformations in your main shapes and drawing rotations and just focus on those rather than feeling the need to go through all transformations at the same time. There is also, if you have students who are very, very comfortable with Scratch and very keen to learn more efficient ways or different ways of coding transformations, there is an extended coding guide among the lesson resources that shows a different way that you can perform these transformations. You'll find a lot with your students as you're teaching them to experiment within applications like Scratch that some of them will find different ways of finding a solution, and that's fine. With coding in general, there is no dictated correct way. Once you understand the syntax and the language and how the language blocks interact with each other, there are many ways to get to the correct solution. And an application such as Scratch is very sandboxy and allows for a lot of experimentation and exploration in that way. So I'm going to return to the slideshow for a moment. And I saw that we had a few questions in Scratch. I believe Max addressed them all, but just in case, I'm going to take a moment before we go to address any questions that might still be, that still might need some additional information. So John's question says, is Scratch Junior only presently available as an application? You are correct. There is no web-based version of Scratch Junior at this time. It is available as a desktop for Chromebooks in particular, and tablet app. I haven't tried it on Apple computers, but I do believe it's available in the Apple Store as well. It is a free software. That is, in terms of its downloadability, it is a free software, but there isn't a web-based version for it that is similar to the full Scratch program. Oh, unless Max knows of one. So I'm just popping this up on the screen. It looks like GitHub has made a desktop version of Scratch. Thanks, Max. It's always great when you have a colleague who has access to different information. So there is a GitHub version of Scratch Junior. It's not one that you would easily find when you go onto the Scratch website. Okay. And it looks like all of our other questions have been resolved. So I want to thank everyone for joining us today for this session and for coding along with us today. Just before you go, if you have a moment to give us some feedback on our survey, Max will be adding a link here, but I believe it will be emailed to you as well. Your feedback is a gift to us that allows us to continue to improve our resources to better meet your needs. And as well, if you have any questions or are looking for opportunities to iterate on the lesson that you saw today, to make it better fit your classroom needs, or if you're really stuck using any of the tools that we've gone through today and would like some one-on-one help from us, we have a team of Blue Coats who are happy to help and to answer your questions if you just send us an email at educators@sciencenorth.ca. So I want to thank everyone for joining us today, and I hope you have a great evening.